show you the
how to
first
simplify
quotient rule
this.
part.
TBH, I agree.
I have no clue how to simplify this. Let's just erase everything I have up until now and do something else.
Or you can deflect it. Did you get that?
No, she can't defect and join your group show. It's
Sure, fine.
Tyler, this is
Yeah, we're right.
Yeah, it's hard when you're like legit and exactly.
She brings her one hand into the phone.
Kiddos, pause.
Implying you didn't know how to do anything.
Kiddos, pause.
Oh.
Eyes.
My eyes are up. Yeah,
Pause.
no, it is the same.
Pause. As a group, look at the work that you have. Was your quotient rule right? You might have this written as a square root, and that's okay. Did you bring down the 1/2? U to the 1/2 is 1/2 u to the negative 1/2 times u prime. Because there's a chain rule. That's a u.
I just removed You did it.
I think you can do it. Let's stay on the bottom. Can you just remove this for a minute?
Pause.
Yes.
Oh, wait, that's you. That's you.
So technically, if you need to, you could have rewritten this to be x over u to the 1/2. This was not an x to the 1/2. This is a u to the 1/2. That's okay. We're learning chain rule. But whenever we have a function inside a function, f would be x to the 1/2, g would be x squared plus 1. F of u would be u to the 1/2. U would be x squared plus 1. Or like we saw yesterday, you guys liked the chain rule shortcut, right? U to the n is n times u to the n minus 1 times u prime, right? So if we look at this, we have a u to the 1/2 in the denominator. So how do I take the derivative? Quotient rule still. But when I go to do quotient rule, bottom d top, bottom stays the same, so I just rewrote it. D top, derivative of x is 1 minus top, d bottom. U to the 1/2's derivative is, does it make sense? 1/2 comes down. U to the, subtract 1, negative 1/2 times u prime. Now you didn't have to plug it all in right away. If you wanted, you could have spread this out. For those of you that didn't get the derivative, you could have done bottom d top minus top d bottom. Yeah, you could have just put it in terms of u and then gone and plugged in, if that's helpful. You can spread it out. But eventually the u does have to come back in, because our answer needs to have only x's. The u prime needs to come in. And then I rewrote the u to the 1/2 as the square root of u, or x squared plus 1, because that's easier for my brain to register why this is going to cancel out. But even here, guys, 1/2 squared, or 1/2 times 2, or 1/2 times 2 over 1 power to a power you multiply, it's going to reduce either way. Whether it's the square root canceling out with the squared, or whether it's the 1/2 canceling out with the squared. Any questions on just the first product? I'm sorry, quotient rule. Are you sure? We're caught up on how the quotient rule happened?
Yeah.
Okay, so now the dilemma is simplify. Now, why do we have to simplify? Because final answers, we're making it match. This would be a multiple choice question. Unless I decided to make it a long answer to give you partial credit, but on the AP it'd be a multiple choice. Because of this right here. Because what does a negative power symbolize?
1 over the
A
square root.
fraction. 1 over. But does that mean I just pop this straight down? No. Because of the minus. So because of the minus and because of this, I have to go ahead and rewrite it as such.
-1.
It's a complex fraction, yeah, the big summer packet. F prime of x equals. I have, no, not straight down. Not straight down. Because look, the minus, this guy is just square root of x squared plus 1. He doesn't have a denominator, right? He just has over 1 right here. I mean, there's the big denominator. But this one, x times x is going to be an x squared. I'll go ahead and write the 2 just so you guys see everything. Do you agree?
Hold on.
Take time.
I want to analyze this.
Take time.
Yes, it's hard to get two. I just left out.
2 in the bottom.
Script.
And 2 in the
Oh,
top.
because you multiply by 1.
X and X makes X squared.
Yeah.
This and only this goes down to a 2.
So you can't bring the whole load of the
Why? The
Because
minus.
of the negative, yeah. It's
sign.
part of it.
Only, remember how we talked about in quotient rule? You have like 2 terms, right? You have bottom d top minus top d bottom. It's kind of like a big old binomial. I mean, it's not technically, but it's like it. I have two pieces up here in the numerator. Only the second one has this denominator. Does that make sense? Sorry. How do I simplify the whole thing now that I see this?
If you remove the 2.
Hold on, we can be, wait. Can't we just get rid of him real quick? Okay, so then the only denominator we have is this guy, right? Yeah, what did we do in the summer packet before we ever talked about derivatives?
Times squared.
Multiply top and bottom by, we never had a name for it, huh? The baby denominator, the entrenched denominator, the stuck denominator, the
Complex fraction.
whatever. The stuck guy, yeah, the part that makes it complex, there you go.
Wait, what if you conjugate that?
Yeah, I need your top and bottom. Okay, now, big old parentheses, because what are we going to have to do? Distribute. Does that make sense? It's like over 1 if you need to see it that way. It's like over 1 if you need to see it that way. What happens when I distribute this over here?
Which is itself squared with
Square root of x squared plus 1 squared, right? Square root of x squared plus 1 squared. Yes, the square root's going to cancel.
minus x squared.
And then Sean just distributed it to the second term.
Oh yeah.
These cancel, right? And all you have left is x squared. Good. On the bottom, you have x squared plus 1 to the 1, and x squared plus 1 to the 1/2. We'll talk about why I rewrote this to the 1/2 in just a second. Now, doesn't the square root and the square cancel? Okay. So then I end up with x squared plus 1 minus x squared. And then Tyler just said 1/2. He's looking at the denominator. Remember what we can do when we have like bases? We add the exponent. So what's 1 plus 1/2? Well, hold on. 1's kind of hard. What's 2 over 2 plus 1/2? Good. The x squareds cancel up top. And there are 2 different ways of writing this answer. Both of them are good. Either 1 over x squared plus 1 to the 3/2. Or if they wrote it in radical notation, 1 over the square root of
X squared plus 1 cubed.
either one's right.
Speed for this would have been easier just to plug in a 1.
There's 2 sides.
What Tyler's saying is, at the very beginning, no, you couldn't plug it in here, you could plug it in here. At the very beginning, could you have plugged in, like, when x is 1, what's this one equal? And then plug in 1 to all the answers and see if one of them matches? I mean, you can try that if you get totally stuck. But ideally, it's probably going to be faster to learn how to simplify. Because this one, it doesn't show up all the time, but remember how, I put complex fractions in the summer packet for a reason, to show up. Especially in the quotient rule. Especially when you have negative exponents in the quotient. My kiddos that were stuck on 27, is this with the back of the book?
Yes.
Yes. Why was it hard?
She was nasty.
Well, yeah, it was a quotient rule with a chain rule that resulted in a complex fraction.
I didn't actually do it right because see the product rule, but could you have, or quotient rule, but could you have moved it to the top and then product?
Yes. The only dilemma if you did that, you would still have to get, because look at this, a common denominator, and you'd have to think through fractions, just not quite in the same way.
Okay.
But you would have had something here with a denominator plus something here without a denominator, would have had to get common denominators, put them together and simplify. Either way, you have to deal with fractions. Alright, kiddos, if you want, let me leave this up here for a second. Go to your homework, number 27. Go to your homework, number 27. You might not be able to totally get down the entire thing, but you can. Number one, it's on the video, but number two, if you want to take a quick picture, remember in homework, we're not just saying, oh, this is wrong. All right, well, forget that. I failed on this one. Let's just move on. Remember, we grade our homework, and then we try to figure out what went wrong, right? So if you have a phone, and if you did not get number 27 last night, please take a picture. If you have a phone, if not, it's on YouTube. It'll be in the notes. But take a quick picture for number 27 last night. We're gonna go into transition. Let's. I had you guys get your work today. Sorry, that was just to not have you in your homework. We're gonna go grade our homework. David, it'll be on YouTube. Whatever you missed. All right, cool kids. When you're ready, let's go grade homework. Anybody else still taking a picture? Okay. All right, here we go. Section 2.4a, the answers are already here, waiting to go. I'm going to go ahead and space this out just a little bit since I have time. Oh, that's pretty good. Kiddos who did homework last night, help me really fast. Where were the LNs found? I mean, not number 6. You weren't deriving in number 6. You were just doing U. But where were the ones?
85.
Yeah.
Those were the only ones. But those are just 1 over x because we learned that in the summer packet.
In summer packet, yes, but not everyone would have gone to large. Number 85 and 87, we're not going to go over today because we're going to talk about the LN rules in section 2.4b. If you remember the summer packet and went and found the rule, you could have done it. Or if you went in the book and you found the rule, you could have done it. But I don't mind if I'm just going to talk about those ones when we check 2.4b. Sound good? Okay. So 85, 87, if you skipped it, cool. Do it as we cover 2.4b. That homework is due on Thursday, but we have a very busy week, so you hopefully worked on Gene Rule last night. That was the expectation, so that you can work on 2.4b tonight and get a good amount of it done. Kiddos, our forever quiz is when? Tomorrow, which is Wednesday.
Oh, that's fun. For forever? Forever quiz tomorrow, you guys.
It's okay, it's okay. Now pause. Pause. What cards did I say the forever quiz is on?
Like 6 through 13?
6 through 14. 14 is the chain rule. Now we are going to cover 15 today, but I'm not putting it on the forever quiz. You just need to have the rules in number 15 solid for Friday. Because what's on Friday, as we talked about yesterday? The test.
Dude, I thought it was. Now you know what that's for.
So only through cards 14, only through the chain rule. And remember, all of the normal credit for tomorrow on the forever quiz is just going to be from cards 6 through 14. A bonus will come from cards 1 through 5. Probably won't be stating the intermediate value theorem or the definition of convenience. Not this time. So if you want to just skip those cards, that's fine. Regular credit will be 6 through 14. Bonus will come from 1 through 5. Okay, kiddos, you should have had time to check 6 and 8 and 20. Let me go ahead and move down just a little bit. Whoa, number 20. Did they solve that a lot quicker, a lot faster than you did?
Kind of.
You guys do quotient rule?
I put it in
just a
product.
power
Okay.
product.
You could have made it a power. You could have
You could have
rewritten
spelled
it if you
power
had
wrong.
thought about it. It would have been u to the -4. I should say -3u to the -4. You could have rewritten it, but could quotient rule have worked? Yes. Quotient rule would have worked. A few of you, did anybody do quotient rule and got it to work? Good.
Oh, wait.
Good. Because when you do bottom, the top, the derivative of the top is 0, so it's not going to be as complicated. Quotient rule does work, but if there's just a number on top, we can rewrite, or if there's just a number on bottom, we can rewrite and maybe make it a little bit easier, but just let you know. Number 50 and number 72. Let me scroll down to let you also see 1 of 6. Fifty was secant of u, which is secant of u tangent of u times u.
Oh, yeah.
Really? For number 50 or 70. Just think u is x squared. Derivative secant of u is secant of u.
Oh, that's
Tangent
what
of u
it
times u. Number 72, what rule had to be used? This one was also another common question from last night. 72. Did anybody have a question on 72? Or had a question at any point in time? Okay, beautiful. Should I show it really quick? Do you guys see why 72 has to be a product rule? Isn't it x squared times e to the negative x? Okay, so be careful. Some of you missed a quotient rule last night. Some of you might have missed this product rule. The most common, not the most common, but one of the most common derivative mistakes is to forget that a rule is necessary. So 72 was a product. When we go to do second d first, we just keep the second. Derivative of x squared is 2x. Plus, now here's where it got a little tricky. We needed the derivative of e to the negative x. Why am I going to say let u equal negative x and u prime is equal to negative 1 when dealing with e? It's chain. So if we had thought of, which we needed to, think of e to the negative x as e to the u. Kiddos, how do you take the derivative of e to the x? Just e to the x. So how do I take the derivative of e to the u? Times? We didn't write this rule down, but it's e to the u times u prime. So for those of you that missed that one, what you missed is that this was an e to the u rule. So the derivative of e to the x is e to the x, derivative of e to the u is e to the u times u prime. So then the negative x gets plugged in, the negative 1 gets multiplied, which is how you get, remember the book always writes it backwards, which is how you get 2x e to the negative x plus negative or minus x squared e to the negative x. If you guys want to, you can always think about their product rule rearranged. We do second d first plus first d second. They do first d second plus second d first. But addition, it doesn't matter. You can go back and forth. I can rewrite theirs in order to make it match mine. And then they went ahead and said, what's in common? Well, e to the negative x was in common, and an x was in common. So they pulled those out. They got it. Last but not least, number 106 was wrong because they killed a bunny.
Yeah, they used.
What? The book was wrong?
Well, wasn't it the point to find a mistake?
Yeah. Oh.
Okay, awkward. So, before you even guys, well, hopefully before you guys even started deriving number 106, how should you have rewritten it? Before you ever started deriving.
The 2
Yeah.
Does that make sense? Remember, don't get tricked by the trig notation. Don't get tricked by the trig notation. Then what did they do? Block squared, bring down the 2, make it a 1. Bring down the 2, make it a 1. Then, cover up the squared. Who's the outside now between these two? The sine, because it's sine of 2x, if that helps. What's the derivative of sine? Cosine of block. Good. And then that one got dealt with, that one got dealt with, last one. Times derivative of 2x. This was an f of g of h, right? It's an f of g of h.
So for number 50.
Yeah.
Why is the answer secant of x squared and tangent x squared?
What's the derivative? Look in your notes real fast. Where are they?
No,
U is x squared.
but isn't u
Pause.
secant? Oh no.
Derivative
Shoot, I clicked them.
of secant of u is secant of u tangent of u times u prime. And this one, sorry, this is in the way now. U equal x squared, u prime equals 2x. So secant u is secant x squared, tangent u is tangent x squared, u prime is 2x, and we just moved that to the front to make it look pretty. Is there one more? 112, sorry. 112. I thought we were done. Oh, they didn't even do a quotient rule. But you could have. They didn't do a quotient rule, although you could have. Top, bottom. What'd they do? Rewrote. Rewrote. U to the negative 2 is negative 2 u to the negative 3 times u prime. Now, could you have done quotient rule? The answer is yes. It just would have been a bit more complicated. Whenever there is a constant on the top or the bottom, you can rewrite before deriving to maybe simplify. So rewriting is a good idea. Rewriting f to be u to the negative 2 is a good idea. And u would have been x squared minus 3x. U prime would have been 2x minus 3. And we could have rewritten this guy to be what's the derivative of u to the n times u to the n minus 1. Or bring down the negative 2, u to the negative 3 times u prime. And that's exactly what they did. Then they went ahead and, remember, that negative exponent needs to pop them down. There are no issues, though, because there's no, other term. So it's just of this whole piece. At which place, they were asking you to find a specific derivative. Which means take the rule such that plug in 4, and that should have been your final answer. I think, was that the one that said check with your graphing calculator?
Yeah, they always do.
Not everyone. Oh, when you plug in a number? Yeah, probably. It's just reminding you your calculator can find derivatives. Guys, can you help me real fast? Just remember how to do that, because some of you have forgotten, and that's okay. How do we find a derivative in our calculator? We can do the home screen, or we can do the graph. Either one's okay, but long story short, do we need this function in our calculator?
Yeah.
Okay. So then when we go to our calculator, oh, lame sauce, there you go. Yes, if your composition book isn't close, get it close. When we go to our calculator, you can do this 2 different ways, but one way is to throw this into your, remember the cool fraction-y button? People without the fraction-y button, you have to carefully do parentheses around the whole denominator. But we plug in x squared minus 3x. I'm going to review both places to do derivatives. At different times, they might be helpful. How do I do it on the home screen?
You do math derive.
Good. Math, and then n derive, which I think is number 9? 8? Yeah, I know, my calculator's really slow. 8, there we go. What do I plug in? Who's the variable that I just typed in my function? F of x. And then how do I get y1? Do you remember?
Second trace, right?
Nope.
Oh, it's alpha trace. Wait.
Alpha, I need to go to trace to get my y bar. And then I'm doing such that x equals what? 4. Plug it in, plug it in. I don't know, is that right? Well, take your fraction and plug it in. Or do math decimal to fraction if you really want. Yay! Dun 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 dun. How do you do it on the graph? Do you remember?
You go to graph. You graph it.
Okay, graph it.
Write it in your graph.
Where do we do all the max, min, 0, intersections, all that stuff?
Second calc.
Good. Second, trace or calc, and then we do dy dx, right?
Yeah.
And then all we have to do is say, hey, at 4, please. Dun 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 dun. Does that make sense?
I will take a 4.
All right. Kiddos, here we go. Back to notes 2-4b. That example looks fun, but let's not for today. Sound good? That was going to be our workspace, but I decided instead to do number 27. We do have some good workspace stuff. We might peek at tomorrow, good AP-ish stuff, but for right now, we're just going to finish the main content. I think that'll be most useful. If you guys want, go ahead and pass up your markers and your whiteboards, and I'll put them, and pass up your rags too. I'll get the notes items.
Oh, and here's another whiteboard and marker. I don't know where it came from, but it did.
That's okay, I'll take it. Bless you. 2-4b, we're talking about logs and we're talking about exponentials. So if you guys got confused by the E last night, no stress. We'll talk about that right now too. Any more reports? Any of you guys have gotten behind on homework? It is what it is, life
I don't
happens.
know.
Maybe it was for good reasons, maybe it was for bad, but either way, if I were you, make a point. Make a point. Make a time. Make a coffee shop. Get in this is the place at home. This is the mood I need to be in. You gotta make it happen, guys. You gotta sit down, you gotta practice. And then any places that you've gotten stuck and you haven't been able to go over homework with us in class, make a point to be like, hey, Ms. D, can I come in at this time and ask you questions? Or have you give me examples? That's how you learn. That's how you get ready for a test. Studying the rules is not enough, but are the rules important? Oh yeah, without the rules.
Why don't you just do a definition?
The definition? Oh, have fun with that. Some of these you wouldn't even know how to, especially the trig. Now you could take tangent, make it sine over cosine to the quotient rule, but even that takes time and it's tricky. If you don't understand how to do it. I want you guys to win the game. I have a basketball poster up in here, so we'll use that. Not learning the rules is like not even having a basketball to play. How can you win a basketball game if you're not even doing basketball?
I mean, how do we win?
Well, the other team forfeits?
I said if you don't have a basketball, it was your guys' job. But don't put it this way without having any tennis shoes. Go out in your stocking feet and flop around and hope that those people don't call socks stocking. That was the phrase. It's like playing a game without tennis shoes. It's not going to go well. Alright, kiddos, this entire page is pre-cal, so as you're writing, you just fill in stuff. This entire page is pre-cal.
To the limits.
Instead of putting the domain problem, well, yeah, we can say that. What I mean by that, this is saying when log does not exist at 0 or negative numbers. And the reason for that is because the domain is whatever's inside greater than 0. This is back from the pre-cal summer packet, right? Domain of log is x greater than 0. Properties of log functions, just a quick review. Any log of 1 is just 0, because that is a log shows an exponent. So basically, b to an exponent of 0 will always be 1. Any base to the 0 power is always 1, except for 0. Huh? Oh, or negatives. This is the product property of logarithms. This is the quotient property of logarithms. This is the power property of logarithms. No derivatives have taken place. None. Not even the last one. These are pre-cal properties. No derivatives have taken place. These are pre-cal properties. Alright, so before we got into logs and exponentials, we had to review the pre-cal stuff. It's in your summer packet. You practiced it in your summer packet. We haven't looked at log a lot, but who's the most special logarithmic function?
We don't need to compare them.
ln. Okay. The one that you're going to enjoy the most, the one that you're going to be thankful to see instead of any other log. The one that is the biggest blessing. How about that? ln. So remember, ln is who?
Log base E.
Log base E. Remember, ln is log base E. And we're going to see why that's super helpful as we get into the calculus. Here we go.
Ooh.
We technically saw it in the summer packet, but a lot of you guys didn't remember A. Because when you faced those two last night, the 80 whatever and the 80 whatever else, you didn't go back and review. Here we go. The derivative of ln of x is 1 over x. So then, using the chain rule that we talked about on the page before, how would I take the derivative of ln of u? Use the rule. Just don't forget to multiply bunnies. Remember the whole awkward conversation? Bunnies times u prime. Bunnies times u prime. Don't kill a bunny. Multiply. Times u prime. Okay. So when we get down below, let's just do some, guys. Let's do them together. On number 1. Oh no, I need product rule. It's 5 times. No, I don't. Why not? 5 is just a scalar or a constant. It's just a coefficient. What do I do with a coefficient whenever I'm taking a derivative? Leave it, right? So 5 ln x is going to be 5 times 1 over x. And what's 5 times 1 over x? 5 over x. Dun 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 dun. Number 3. Oh, no, let's go to number 2.
Oh boy. Wait. Oh, I'm looking at the
Derivative of 5 times ln is 5 times 1 over x. So derivative of 5 times ln is 5 times 1 over x. That was the most basic one. Number 2, though. Ooh, is it just 1 over?
No. I mean, you added the chain.
Because I have a u. So if the u notation makes sense, u is 3x cubed. What would u prime be? So can't I rewrite this to be ln of u? I'm just taking my time and showing all of the work. U is 3x cubed. U prime is 9x squared. Since y is ln of u, then what's dy dx going to be? Check it.
What is it? It's like 1 over u times u
Yeah.
prime, but
1 over u times u prime, which is going to be, who's u? 1 over 3x squared. Sorry, cubed. Who's u prime?
9x cubed.
Another way of thinking about it is, ready? Another way of thinking about the rule, if it helps,
That's fine.
is u prime over u. It sometimes makes it faster. But I like the 1 over u times u prime because then you're remembering 1 over x is 1 over u and then you're multiplying chain rule. But we can simplify, right? You guys see it's 3 over x? X squared reduces with x cubed. 9 reduces with 3. 3 over x. Wait, what was that?
No.
Oh, okay. Now questions on 1 and 2, those are like the basic ones. You had an ln of x with a coefficient, and you had an ln of u. Before we go on to 3 and 4, we got to make sure we got 1 and 2. Alright. 3. You guys tell me, what's the big rule at play? Yeah. Do you see it? Did you all see it?
Yes.
X squared times ln of. This isn't ln times, it's ln of. X squared times ln of 5x plus 1. Now if I were you, I would say u equals 5x plus 1. U prime equals 5. Some of you just think this and it's enough. Some of you though need to write it and it will make it easier for you. If it helps, whether you think it or whether you write it, you're taking ln of u as the second. So, product rule. Second d first. Plus first d second. Now once again, do you have to write all the u's and the u primes? No, you can actually be plugging in. But if you need to, if it's easier on your brain, you can rewrite it with the u. Second d first, plus first d second. Derivative of ln of u is 1 over u times u prime. But who do I need to plug into all that? Yeah, all that stuff, right? So, ln of u, I'm going to move that 2x to the front. U is 5x plus 1, right? Plus, oh, careful, it's just x squared. But 5x plus 1 does need to go in the u spot.
Oh, I need to do.
So I'm going to have u prime, which is 5, times x squared, all over 5x plus 1. I'm going to zoom in because this answer got a little complicated, and I apologize for that. Sure. Well, that didn't help at all. Let me scroll down. So the 2x comes in front for simplicity's sake. 5x plus 1, the u gets plugged in. Plus u prime was 5. 5 times x squared all over 5x plus 1. Do you guys see it? How many of you think writing the u's out is going to help you? Because it simplifies it, right? Like it kind of gives you a break so you don't have to do everything all at once and be overwhelmed. Can anybody see what the big rule is for number 4? Is it product? Is it quotient? Is it? Do you see why it's changed? Some people last night got confused. Some kids in here working on calc. So I don't get it. Isn't this times?
Because it's the
Tangent
of.
It's tangent of.
It's
But I know your brains, and some of you are going to look at this and think it's a times, but it's not. It's tangent of, ln of. It's tangent with something inside, ln with something inside. Do you see the F and G and H?
Mm-hmm.
Yeah, we can do block. So we're going to do the words. You ready? Okay. dy dx. You know what? Hold on. I might rewrite it first as the 1/2 power. Is that okay? I might put a parenthesis in too. One more? No, that's enough. Okay, ready? What's the derivative of tangent of block?
Secant squared block.
Is that okay? That's a rule we got to memorize. Secant squared of, and who's the block? Ln of x to the 1/2 times.
Peel away.
Peel away the tangent. I'm going to cover them up, yeah?
Yes.
Okay. What's the derivative of ln of block? Or
1
ln?
over block.
1 over block times block prime. Does that make sense? From up here.
Yeah.
Okay.
1 over u times u prime. So I can say 1 over block times, okay, peel off the ln. Who's left?
Okay.
How do I take his derivative?
1/2
Power.
Oh. 1/2 x to the negative 1/2, right?
Yeah.
So did I deal with the tangent? Check. Did I deal with the ln? Check. And did I deal with the x to the 1/2? Check. So I dealt with the outer, the inner, and the innermost.
Okay, so the 1 over x 1/2 is the outline, right?
Is the 1 over u, yeah. And that's that new rule that we're still
Mhm.
trying to get used to. So now we can go ahead and say, all right, well, wait a minute, isn't it like one big old fraction? This guy's on top because he doesn't have a denominator. I'm going to write square root back because that's how it was written originally. And then down here I have 2 square root of x times, oh hey, there's another one, right? Because I have a 1 over from the ln, but I also have another 1 over from this negative 1/2 power. Does that make sense? X to the negative 1/2 is another 1 over x to the 1/2. And what happens when we square root, whole kids? Yeah. The squared and the square root just ends up being, or canceling out and just having the x remaining. Dun, dun. Does that make sense? Okay, but do we have a new rule we need to get used to? And the answer is yes. The derivative of ln is 1 over x. The derivative of ln of u is 1 over u times u. Now, what if we have a log that's not ln?
You're gonna cry.
You told me I shouldn't discriminate, but I was just stating the truth when I said you'd much rather see an ln. We would actually have to use the change of base formula to put this log into ln's.
Oh my gosh.
Change of base formula says to change the base, take a new log of the argument, which is x, over a new log of b. Now the good news is you're not going to have to memorize this unless you don't memorize the rule for the nasty logs that are not ln's. There is a rule. But I'm showing you where the rule comes from. What if we needed to take a derivative of this guy? Well, we could take the derivative of this guy. And I think the derivative needs a quotient rule, right? I'm finding a rule. Don't stress too much. I'm finding a rule like I did with tangent and secant and cotangent. I found rules for those. I'm doing that here. Bottom to top. Derivative ln is 1 over x minus top. Here's where it gets tricky. Who's b? Base. And if they give me a log base 2, log base 3, log base 7, I'm trying to make a rule that works for any of those, but all of those bases are constants. Could you plug in ln of 7 to your calculator and get a number? Could you plug in ln of 2 and get a number? How about ln of 12? It's just a constant. So when I go top, D, bottom, the derivative of any constant is b would just be a number. Ln of b is still just a number. The derivative of ln of b, that number is just 0. All over bottom square. At the end of the day, you get ln of b times 1 over x all over ln of b squared. Since this is multiplication, I can reduce one of the ln of b's. This is kind of nasty unless you simplify him. It's a complex fraction, but if I multiply top and bottom by x, now, even though that was fun and all, can we look at this rule that will always happen when we're taking the derivative of any log other than ln? And can we ask ourselves, is this kind of close to what ln's derivative is? The 1 over x is still there. But where the x occurs, we have to say, ooh, but the base was different, and we need to add in an ln of b. The 1 over x is still there, but we need an ln of b. So when we go to take derivatives of logarithmic functions, for ln of x, it's just 1 over x. For ln of u, it's just 1 over u times u. The cool thing is, for ln, actually absolute value makes no difference whatsoever. And for log base b, we're going to say, you know what? It's so similar that we're just going to memorize the rule and not have to do that crazy quotient rule all the time whenever we have a logarithmic base. And all that changes if it's of a u is make it 1 over u ln b times u. What do you guys think this is?
A forever car. Oh no!
Now, pause.
Are you
We're
gonna
still
put it on
supposed to take pause. We're still supposed to take a whole other day on 2,4b. Okay? Because we talked about logarithmic, but in the title, don't we also need to talk about exponential? So there's a whole nother half to 2,4b. Guys, is this forever card on the quiz tomorrow? No. No. So don't add this forever card in. We still need to master it. We still need to practice with it. Study your other forever cards for tomorrow. Start homework on anything with logs. But the good news is, to be honest, use tonight to catch up. We need a whole other day on the lesson. Bye, guys.
Here's your book back.
Is that your business book in the back? Okay. Just know it's there.